In this video, we're going to be doing a problem from the textbook on acids and bases. We're going to be doing problem 2C on page 377. So the problem states, for each of the following reactions, indicate the bronzodilary acid and base. What are the conjugate acid-base pairs? So the reaction for 2C goes as follows. So first notice that the reaction goes both ways because that's important. And then it's asking us to indicate which are bronzodilary acids and bases. So first, if you need a refresher, a bronzodilary acid is a substance that can donate a hydrogen ion. So they're often referred to as proton donors. So just think of it as that if it can donate the hydrogen ion, it's a bronzodilary acid. And then the bronzodilary base is any substance that can accept a hydrogen ion. So they're acceptors, the bases. So looking at this reaction, we know that the HC2H3O2 is an acid because of this hydrogen here. It can donate, so that would make it a bronzodilary acid because it has the ability to donate the hydrogen ion. And then next we have HS minus, and this would be a bronzodilary base because it has the ability to accept another hydrogen ion because of this charge right here, and the fact that a hydrogen has like a +1 charge. It would be like easily able to accept another hydrogen ion, so it's a bronzodilary base. Next we have C2H3O2 with -1 charge, and with this charge it can easily accept another hydrogen ion, so it'd be a bronzodilary base. And then last we have H2S, and this compound has the ability to donate its hydrogen ion, so it would be a bronzodilary acid. So with all of these, like identifying the acids and bases, we can then find what the conjugate acid-base pairs are. So here, before we do that, I have written out which ones are the bronzodilary acids and which ones are the bases. And then a conjugate acid is a species formed after the base accepts a proton. And then a conjugate base is a species formed after an acid donates its proton. So looking at this reaction, we have this substance here, and then when the reaction goes to the right, we see it appear again over here, but without its hydrogen because it just donated the hydrogen. So the first acid-base pair would be HC2H3O2, and that would be the acid, and its conjugate base would be the C2H3O2 minus, and it's a conjugate base because it's what's formed after the acid originally donates its proton. And then we can do the same thing, but going to the left this time. So if we start with our base, and then we look for what would be its conjugate pair, we see it appear on this side again, but this time it's after it accepts the base. After the base accepts the proton, so that means it would be a conjugate acid. So that's why I said earlier the double arrows are important, because these base pairs can go both ways depending on the reaction. And then the other pair would be the HS minus, so this base, and then its conjugate acid would be H2S if we go to the right, because it's after the base accepts the proton. And then it can also go the other way around, if we start with the acid and then we look on the other side what happens after the acid donates its proton, we see it here, so that would be its conjugate base. So the conjugate pairs are as follows. This is one pair, and this is the other, and since the reaction goes both ways, we can't really label if it's a conjugate acid or base pair, but because it could be either depending of the direction of the reaction. I hope you enjoyed this video. Thanks for watching.